recording.
Well, hang on. Did we figure out who caller 3 was? Did anybody not get to introduce themselves?
Good question. Probably someone just didn't do the the alignment of the call number.
Yeah.
All right. We'll get started. Okay, so today is July 6th, and we're going to talk about adding temporality to relationships, that is to say, properties in OWL. So quick overview, we're going to introduce what we mean by the very idea, and then we're going to explore, well, what exactly is that, kind of from an ontology perspective, and how do we model it? And then look at when need arises for them, consider some examples, and then there's actually a variety of caveats, which is Mike hinted, hey, we're struggling with this, and boy, so have we over the years. So this is really just a lot of gathered experience and what we currently do now, so hopefully it'll be some use to you. Okay, so consider the following relationship, simple everyday relationship. Somebody is employed by an employer. The business has a business address, which is some kind of postal address, or a manager supervises some member of staff. That's all very nice, and we can model those things as simple OWL properties, and we do just fine. However, what happens if you change your job, or you get a different boss, or you move, right? So what happens then? So really, these relationships, although on the surface they just seem quite simple binary relationships, actually they take place over a period of time. So employment, you might have a job from February 08 to September 09, or you might have an established location from a certain date period, or you're managed by somebody for a period of years and then you have a different manager after that. Now it turns out that OWL does not support timestamps for triples. So the question is, how do you address this? So what we do in GIST, and there is a class in GIST called temporal relation, and it represents a relationship existing for a period of time. So you're employed for a period of time, you reside at a place or have an official business address for a period of time, etc. And we create that as an OWL class. Now, something existing, a relationship holding or existing for a period of time is not sort of an everyday concept that rolls off your tongue and is super intuitive. So the real question is, how do we think about temporal relation? What is it really, and how do we put it in the ontology? What common sense thing does it correspond to? Well, let's look at it. So it has a start time, it has an end time, and often something is happening during that time. And if something's happening, then it's an event. So maybe it's an event. So some temporal relationships, it might think of them as events. The event of my being employed at Semantic Arts, or the event of my being supervised for a period of time. But not everything can reasonably be thought of as an event. So a person being a citizen of a country for a period of time, or a person living at a street address, you don't really think of those as events, or things that Procter & Gamble worries about, a chemical having a trade name for a period of time. Well, you wouldn't really think of that as an event. However, what's interesting is, while nothing is happening during that period of time, something is true during that period of time. And what's true or what's not true is caused by events that happen that initiate and terminate these periods of time. So you become a citizen or you become a non-citizen. You move in or you move out of a certain residence. You assign a trade name, you remove a trade name. So events are relevant, but the temporal relationship is not really the event. So some of them seem to be events and some don't. So we can't make it a subclass of event. So here's just a quick little Venn diagram. So supervision and employment, you can think of things happening. So you might reasonably think of those as events. But things like snap your fingers or open a bank account, they're actually events, but you wouldn't think of them as temporal relations. Or these other things we just talked about a moment ago, being a citizen, having a trade name. They're temporal relations, but we don't really think of them as events. So we're not going to have temporal relation be an event. But we don't want to have an orphan class if we can avoid it. Sometimes you need to put a class at the very top level of the hierarchy, but we try to avoid it if we can. So what is temporal relation a subclass of? Well, one thing that we want to do is look at what's really true about temporal relation fundamentally, and it has a start and an end time, right? So that's a good place to start. And so does every time interval. So we just decided, well, let's just make temporal relation a subclass of time interval, and then every temporal relation will inherit that start time and end time. So this is what our tiny little snippet of our class hierarchy looks like in GIST. So we have time interval, and temporal relation is a subclass of time interval. Okay, so what does it look like formally? Well, on the right-hand side is our internal notation that's formal OWL that exports to to RDF. So it's a subclass of time interval. It's an OWL class. The definition there is a relationship existing for a period of time. And then we just got a few examples there in the comment. It always has a start time. It always has an end time. And it's always connected to at least two other things. And those are going to be the things that are related. So if it's supervision happening over a period of 6 months or 2 years, you point to the supervised entity and you point to the supervising entity. So there's always two things that you're connected to. And that's pretty much it. It's not real complicated, but those are the key elements. Now, interestingly, you would like to be able to point to the relationship that is being temporally adjusted, but in OWL you can't point to it. So you'd like to have this point to the property supervises, but you can't really do that except through an annotation, because that takes you out of OWL 2. Okay, so let's consider then when to use temporal relations, when you might need them, when you might not, and what it actually looks like. So whether you just look at two different options, the simple case, and then when you don't have temporality, and then when you do. So the simple case, you don't need temporality. Simple relationship supervises. So the domain and range are both people. It relates one individual to another individual that they are supervising. Pretty straightforward. Links to people, ordinary triple with subject, property, object. You just say person, Jill, supervises Joseph. Now we have a convention here where the main property going in the direction is in bold-faced, and just if we happen to have an inverse property, we put it in parentheses down below. So this simply means the property going the other way. So you'd say the person Joseph is supervised by Jill. That's just our own internal convention. Okay. Well, the second option is to make this a temporal relation. So now we have supervision, which is a subclass of temporal relation, and it has these two things that are the connections. So you connect to the person doing the supervising, and you connect to the person being supervised. Okay, and so we represent these as properties. So supervision by is the domain is a supervision, and it points to a person. It relates the supervision to the individual who is doing the supervising, etc. And supervision of is just the flip side. It also has the same domain and range. And also, given that the definition of temporal relation always says there has to be two things connected, these things then become subproperties of just connected to. This is a generic property in GIST. Now, what's interesting here is because we have this as a subclass of temporal relationship, I didn't indicate the dates here, but the dates, the start and end times are inherited from the temporal relation class. So here's what it looks like. So you have the supervision, which is Jill supervising Joe from 27th of April 1984 to the 21st of July 1990. And then you point out from this temporal relation object supervision by Jill and supervision of the person. Okay? So there's two different ways to do it. Do you have to choose exactly one or the other? Sometimes you need it one way, sometimes you might need it the other way. What you certainly don't want is to have two different ways that don't somehow relate to each other. You want to be able to do both if you need to, but somehow link them so one is kind of a reflection of the other in some way. So how might that work? We can do that, in fact. So again, here's a simple option. Jill supervises Joseph. And then here's the second option where Jill, the supervision is the object itself, which has the start and end date pointing to the supervisor and the supervised. However, what we want to do is turn this around and make a property change. So we're going to use the inverse here. Instead of supervision by pointing from here to there, we're going to flip that around and say, we'll use the inverse. So this person does the supervision. Now that's a bit of an awkward name. There's no good way to think of wonderful names all the time for these types of things. We'll talk about that a little bit later on. So now we have essentially a property chain. So person does the supervision, and then it's the supervision of person. So we can just kind of click these up here. Those things snap together, and now we have what essentially is the third option, where we have both option 1 and option 2 working together. And we want to link them by a property chain. So OWL, it turns out, will give you the ability to define property chains. So you can define supervises, this link that jumps over the supervision object, and you can just say, well, it's a chain between does supervision, and then chained after that is the supervision of. So you can actually do this in OWL, and so that's an option that you can do. Now, we have a real-world example of this. We had...
Hang on, Michael.
Yeah.
You want to do the caveats now while they're there, or are you going to talk about this later?
Back to that. I'm going to come back to this.
Okay.
Hold on.
Okay.
I don't know if I somehow missed it, but I think we're going to come back to it. Thanks. Okay, so the real-world example, we at Semantic Arts, we have an internal system, a production system that is based on an ontology, and we have everything in the triple store data-wise. And we track projects and proposals, and it includes billing rates. So different individuals have different, the junior people make less money than the senior people, and the different roles have different billing rates also. So programmers, ontologists, program managers, etc. And what happens is over time, people get promotions, and then their billing rates will change. So initially, we just did the simple option, and then we realized, well, even though it doesn't happen very often, we do want to track the fact that, a person had a billing rate at one point in time, but now they have it at a different point in time, or they have a different rate at a different point in time. So we created a class in our internal system. We made some changes to the ontology. We added a class called billing rate assignment, which means a person having a billing rate for a period of time. So it's completely analogous to, Joe supervising Jill or vice versa over a period of time, except for it's not an event, it's just a person having a billing rate, but it's still a temporal relation. Now, most of the time, you really just want somebody's current billing rate, and the historical thing is really just that, looking back over history. So you can have a property in OWL called current billing rate, because that's what you're most interested in. You can't specify the semantics of it in OWL, but you certainly can write Sparkle code to compute that. So you just walk over all the billing rate assignments for a given person, and then you pick the one that's the latest. You do a bit of comparison and the dates, and then you're good to go. The one thing you want to do, just for data integrity's sake, it's possible to mistakenly put in time periods that are overlapping, but that doesn't mean anything semantically. So again, write more Sparkle to walk over your triple store and make sure that that hasn't happened. That's an example of a more generic thing to make your database have integrity. We write lots of Sparkle queries to ensure things are true that we know should be true and to avoid errors. Okay. Now, we actually did this, as I said. So Dave, we had years of data in our triple store. We made those changes in addition to the ontology, and then we need to somehow upgrade the triple store. I'm not going to say a lot about this, but we do have a video, and they got the link right there. So I think you'll see this when we get the video. Dave describes in the 17-minute video.
Michael, is that a typo? Is there really a dot in the middle of YouTube? Gosh.
That's weird. I just copied and pasted it. Yeah, it does actually seem to work. That's weird. Maybe that's weird.
No, that's normal.
Yeah,
it happens that way.
Oh,
Yeah.
does it? Ah.
That's the shrinker.
Okay.
So Dave,
Wow.
do you want to say a quick comment about the highlights of that experience?
Well, the first thing is, we're sitting here talking about temporalness, and it may seem like it was obvious that should have been a temporal relation, but in fact, there's very little, in most cases, somebody's billing rate does not need to be temporal, and our case is sort of the unusual one because of the way we calculate people's pay is based on their earned revenue over the last 12 months and all this strange stuff, we actually did have a need to go back and recalculate things based on what was the billing rate at that point in time. So a little bit of this talk is kind of sorting out when do you need this and when don't you, because it does add a little bit of complexity. But the other thing that was kind of fun in doing it is how you can just take a live database and update it in place, and then just keep going. Obviously, you have to add a few extra queries so that, going forward, you have to be able to say what was the billing rate at this point in time or what is the billing rate now. But other than that, I think it's kind of a neat little case study, because it sort of reminds you don't absolutely have to get everything right up front. You may change your mind about something later and be able to shift to it.
It's part of the broader story of why semantic technology is, some of the advantages of semantic technology. It's that flexibility thing. So quite independently from this example having anything to do with temporal relations, you can make, a variety of changes to your schema, enhance the model, and just go back and write queries and updates and change the data. Now, it's not an easy process, and you have to be very careful, but it's relatively doable, and we, in fact, did it on our relatively small system. But I think this type of thing isn't really even doable. Nobody would contemplate making changes to a data schema for a production system, for the most part. Okay. Any comments or questions at this point?
Yeah, Michael, this is Dan. And I don't know if you get to this later or not, but in defining a temporal relation of something that has a start point and an end point, what do you do when you don't have the end point yet? For instance, I have a residential address and I'm still living here. So there is no known end point. How do you?
That's actually a great question, and I did not put that in this talk, so thank you for bringing it up. Dave, what is our standard answer to that? We create something called infinity, more or less, don't we? A kind of artificial time point?
I mean, there are two approaches, and you should just pick one and be consistent with it. Either you have no value there, and do your comparison like that, but I think it's easier to just have an arbitrarily high value. And in our case, just because it's easier, we count the number of weeks since we started our billing system, which is, we're now in the 445th week. So we've been doing this for whatever that is, 8 years or 9 years. And we, at the moment, our arbitrarily highest number is 690. I'm not even sure why. We used to load it up 10 or 15 years worth of weeks, which is just the easiest way to do that comparison. But the other thing you bring up, Dan, which I'm not sure we're going to get to here, is in GIST, we have two kinds of start and end. There's actual historical things that have really happened. So the day you moved in your house is an actual start date. And in many cases, you can have a planned end date. So like a product that's going to go, for planned obsolescence or whatever, if we know when it's going to be discontinued, that's a planned end date because it hasn't happened yet. But the temporal relation will work either with historical or planned dates.
And when you're missing an end date, that makes if you have data integrity otherwise, that makes the query to find the most recent one really easy, because you just look for the one that doesn't have an end date yet. You don't have to do any max or sub-selects and stuff like that.
That's kind of what I was thinking would be done by, not having that end date. It does have some upsides to it.
Right.
Well, you might also consider putting a flag on it that just says that, or inferring a flag to make it even easier, because looking for the null in the triple store is harder than looking for the fact in the triple store from a performance perspective a lot of times.
Yep.
Thank you. Okay, so we're going to move on.
Michael,
yeah,
I
go
don't
ahead.
know if this is the right time to ask the question, but
Sure.
I mean the other kind of obvious, or I don't know if it's obvious, but the other kind of approach that you for handling this would might be to like reify triples or something. Is that something that you've considered or tried before in terms of handling temporal relations?
Well, this in effect is reifying a relationship. You take the relationship supervises, which used to just be a property going from person to person, and now you make it a thing. You make the fact that Jane is supervising Joseph a thing, and you give it a start date and an end date, and so that is a reified relationship. It's just like marriage.
Yeah, I'm just saying, I guess I'm just speaking like sort of syntactically, right? That you're actually just you would just have the triple in your triple store, and that thing becomes a reified object, and you would then you add start dates and end dates to it.
Right.
I mean, effectively, but sorry, go.
So Michael, I would say what we're doing is not quite reification, but I call it nominalization. We're turning a verb into a noun, and we're creating a class where there was a property. Michael's right, but reification is not really OWL, it's RDFS. The one other thing, and we have screwed around with that a little bit, it's actually a fair bit of plumbing to get that right. The one other thing that we're looking at now, but I also think it's going to be more work, but it might be worth it, is to take the named graph and have that as a URI. We're already attaching provenance information and a little bit of security information to the named graph URI. I think we may want to think about generalizing the idea of date effectivity and sticking it on attaching it to the name graph, which is essentially is sort of like reifying the triple then, because the triple can be attached to a particular fine-grained named graph to be able to say when that became effective.
I'm glad you
explaining the quads idea, and then you can associate properties with I mean, frankly, this is what you're presenting, Michael, is probably sort of the way I sort of feel most comfortable with as well. I mean, because you're actually really kind of getting at the semantic underpinning of it, right? Like what is this thing that we're talking about, and explicitly saying, reifying it as a temporal relation, et cetera. But I'm just wondering if you those other ones. So
I'm actually intrigued by Dave's comment, and it raises an important point. So Dave said, no, it's not reification. I'm thinking to myself, yes, it is. And then I realized that there's like always, there's an ambiguity in that term reification. So Dave is referring to the reification in the technical sense that RDF uses the term. And that really does literally turn a triple into a thing, and then you can have the triple be a subject or object of another triple. So that's RDF reification. But reification in a broader context, a logician or a modeler, that really is exactly what we're doing. So it's important to know that the term reification here is a bit ambiguous, as are almost any other terms. Okay. So temporal relations, there's no easy lunch here. There's workarounds and all sorts of things that aren't as easy as you want them to be. And gosh, we've struggled a lot about this over the years, and we've gotten a lot of experience. So we'll just go through a few of these caveats and challenges. So one is property chain. So yes, I can create a property chain, and OWL does support the property chains, but it only provides limited support. So I'm not going to go through the details. We have slides on this from some of our DBBO classes, but some of the inferences that you'd expect to work just don't work. Because it's really giving you a limited sense of property chain. And also, it turns out, and we got burned by this. If you want to use a property like supervises, and it's defined to be a property chain, you want to say somebody supervises. Say like a busy supervisor. I'm just making up an example. Is someone who supervises a minimum of 20 people, right? Well, you just can't do that. If it's defined as a property chain in OWL, you can't use it in a cardinality restriction. OWL has a variety of limitations that come from the finer nuances of logic, and they made those simplifications to get better reasoning, and it's just one of those things that bites you in the butt. And so there's ways to work around that. So, for example, one way to work around that is just to don't use the property chains in OWL. And instead, when you need to do a property chain, I'll just do it in Sparkle on the application side rather than in the model side. However, if you're going to do that, you might want to say in your comment, like, so you have the relationship the property supervises, and you might want to put in that a comment that says, hey, by the way, this really is a property chain connecting does supervision and supervision of, so that the developers and anybody writing application code and Sparkle, they know, oh, I see, that's what that means, and then they know how to use the property. They know that they're supposed to use the property chain. So that's one thing you can do. The other thing you can do is you say, well, I like property chains and I want to use them, and so you use them in OWL. But as I said, you don't get all the inferences you need, so then you figure out which ones work and which ones don't by experimentation. And the ones that don't work the way you want, you can use Sparkle to get that to happen. But with this approach, you have to not use the cardinality restriction. Now, interestingly enough, I was just looking at our gist, and we used to use property chains, and so we literally did this second workaround some time ago. We took out the minimum 2 connections and just put in some connections as 1, and then we had a comment saying, by the way, there's really 2. But now we don't use property chains anymore, so we don't have to do that anymore. And again, you want to put, whenever you're doing something that's OWL limit, whenever you're doing some kind of workaround, you're doing something that you'd prefer not to have to do because of OWL's limitations, it's always a good practice to put a comment in there to say what it really means, and then that's kind of a hint to developers, so they know to do the right thing with the semantics of what you're defining. So that's property.
Hang on, before you leave the property chain, I mean, the real caveat there is that OWL will disregard the dates, and so anybody who's ever supervised anybody is going to have the supervised relationship. And generally, occasionally, that's what you want. You might say has ever supervised or has ever lived in this building, because that's now if you hop over the dates and you run inference, you get all those. Probably not what you want, but occasionally it would be what you wanted. But you really got to ask yourself, do you want a link that is date independent hopping over those things?
So that's good that you pointed that out, Dave, because I hadn't thought of it. Is it my belief, and I'd like you to confirm or comment on this, my belief is that we started doing things this way with the workaround 2. We used property chains and we gave up the cardinality restrictions, but now we more or less do this. Is that accurate to your understanding? We don't use property chains in OWL anymore.
Correct. Yeah. In fact, there's two Sparkle ways to do it. You can do it at query time, which is what a lot of our things do, or you could periodically run a Sparkle insert query and put the current link, then just periodically delete it and put it back when something has changed. But we're doing more. Most of the stuff I think we've done now is do the chain on read, isn't it?
Yeah. Usually we query it live. There are a few things where we run a cron job to just make inserts to maintain something that we need, but for the most part, you can do it at runtime.
Andy, can you sit a little bit closer to the speaker? We can hear you, but it's a bit soft. Thanks.
Sorry.
Okay. All right. So next, dates. Now, dates are pretty important when we're talking about temporal relations, but it turns out dates are a real headache in OWL. So the backstory is the creators of OWL, they actually didn't just start from scratch and make a bunch of data types. They just looked at XML schema and said, we'll use those. But they didn't use all of them. They selected a subset, which is nice on one hand because it's easier to manage a much smaller number. But it turns out one thing that you don't get very much of is dates and times. You basically get just one option, and it's date time. Now, technically, there's a second option that's called date timestamp, but it's really not different. It just means with date timestamp, you have to have a time zone offset, whereas date time, it's optional. So I'm just going to talk about date time and not worry about the other one. Okay, so dates in OWL2. The date time data type is a concatenation of what is an XSD, the date, followed by the time. There's also a time zone offset. So this is one of those fiddly things that you just have to, struggle with initially. So here's some examples, right? So 7:30 a.m. on March 29th, 2017. So here's the it's YYYY-MM-DD, and then this is time, 7:30, 0 seconds, and then this is a little indicator that says this is a literal whose data type is date time, right? Now, what's interesting is you have the option to specify a time zone, and if you use Z, that just means coordinated universal time, which is the standard. It used to be called Greenwich Mean Time. I'm not sure what the difference is, but the current terminology is coordinated universal time, which everybody just calls UTC. Or you could have a number of hours offset. Now, this would almost always be on the hour, but there are some places where they have it on the half hour. I don't think anybody has it on the 15 minutes. But anyway, this would essentially be 7:30 a.m. U.S. Standard Time, which is 5 hours different from Coordinated Universal Time in London. So these are examples. So what's the limitation? Well, it forces you to specify a time, even if you don't care, right? So you can't just say March 29th, 2017. And most of the time, that's all you want to say. When were you born? That happens to be my birthday, not the 2017, of course. I'm not a babe in the woods quite yet. So what do we do? So there's three possibilities here that I'm going to name, and there's probably any number of variations and nuances. But so you can stay in OWL2 and use a programmatic workaround, or you can stay in OWL2 and kind of create your own custom ontology, or you can just leave OWL2 and say, the heck with it, I'm just going to use XSD date because I feel like it. So we'll look at those and what that entails and some of the pros and cons. So the programmatic workaround option means you stay in OWL2, you just use the one data type called date time, and then you just make up a convention to say, well, if I'm using this convention, then I only care about the date, but I don't care about the time. And we talked about that briefly a moment ago. So here's one example of a convention that you could use, and I think we did this for a while. If you only care about the date, then just say arbitrarily, if it's 00000, that means I don't care about the date. Now you have to enforce this programmatically. OWL isn't going to do anything to help you there. Now there's this tiny theoretical disadvantages. Now you can't ever distinguish between 00000 and between the first second and the second of the day. But honestly, that's hardly an issue. So this is something that could work. Now, Dave, we did do this for a while. Do we still do it now or not? What's the story?
We're moving to have, well, we now have 3 subtypes of time instant and gist for the 3 levels of whether you want just a date or time to a human level or time to a system level.
Right. So that's kind of, it takes us to the second example. If you have different needs, like you want to specify just the date, or in like the finance industry, in fact, across all working, there's this notion of, 2 working days later. So you want to be able to do some kind of date math. So what we've ended up doing is for those things that we need that aren't standard, we just create our own little ontology. We have things like work week, as Dave mentioned earlier. Now you can go crazy and create a whole new date time ontology with everything you do from scratch. OMG has a standard. FIBO uses it. I think they may have made some modifications. But again, don't go crazy. Just do as much as you need, as we have done. So lastly, you can just say, well, the heck with this nonsense. I'm just going to use XSD date and whatever else I feel like using from XML schema, and some people will do that. And essentially what you're choosing to do is say, well, we're going to live in the world of RDF and linked data, and that could be okay for you. But the trade-off is this is what we sort of stuck. You see XSD date and you say, oh, that's what I want. And then you run the inference engine. Some of the OWL2 reasoners, they just choke. They just complain. They say illegal data type, and you're like, what? Come on, give me a break. But that's just the way it is. So if you go with this route, then you will reduce your ability to detect certain logical inconsistencies, and then you have to depend on a lot of manual. For those inconsistencies that you really care about, you'll be writing individual Sparkle queries to go out and detect these kinds of errors. The other caveat we mentioned briefly earlier is date math. It's actually quite tricky. you actually can't have a date and then add or subtract a duration to get another date. That's what you really want. 30 days from, July 2nd. Owl doesn't do that. Sparkle doesn't even let you do that. Dave has spent a lot of time, messing around trying to get that to work. So one way to do it that Dave has been working on, and I'm not sure if we have this implemented or not, Dave will comment in a moment, you just kind of parse out the different pieces, which is a real nuisance. So you pull out the Y, you pull out the M, and you pull out the D, and then you do math on individual pieces, which is incredibly fiddly. You can get that to work, but it's kind of fiddly. So what we're doing now is we're saying, well, we're just going to go back to what's called epoch time. And now you can actually do the math. Now, Dave, you've started doing that now. Maybe you want to comment briefly on how that's working.
So it's in the current version of GIST. So there is epoch time on the time instance, but it has to actually be implemented in the architecture. So you have to whatever posts a date to your triple store has to also convert and post the epoch time. And, once you do that, you can then do math on the epoch times and all that kind of stuff. So it's not entirely implemented in our architecture.
How would that deal, if you're a big global company, like a lot of companies are, how does the time zone thing work if you're using epoch time?
Well, it's Greenwich
Mean
Time.
It's regarded as the UTC, okay.
Yeah. Yeah, in fact, what we're suggesting right now, which we just haven't implemented, is that you should store the local date time, the universal time, the universal epoch time, and the precision, which is, I want it to the millisecond, to the second, or to the day.
Right, or even down to the month is weird and bizarre because there's different numbers of days in each month.
Yeah.
Okay. Now, the final caveat is names. Now, I've actually got a fair amount of material here, but I'm going to skip over some of it. And if you want, I can send you this deck, I suppose. So the reality is, it's not always easy to come up with names. Now, I came up with names that are kind of reasonable. You can make a sentence, and it's not the most stupid sounding English you ever could imagine. You can kind of get the idea. So I just kind of had a convention. If you go pointing out from the temporal relation object, you just say supervision by or does supervision, and then going the other way, supervision of or has supervision. So here's just a quick couple of examples. So Jill, so the employment, is in points this way. Jill does the employment, and it's employment by. So the has employment and employment of. So these things kind of work, sort of. It's not the worst thing you can imagine. But then there's other examples like being a member or owning something, where these words are just kind of awkward. Does membership of, that just kind of doesn't make sense. So sometimes you just don't know a good name to use for these things, right? Does a club have membership, or does a member have membership? Does membership and does ownership, this doesn't sound right. A car has ownership, that really doesn't make any sense. Maybe you could say the car is owned via the ownership. That sort of makes sense a little bit more in English. It's not a common expression you'd ever use. So the point is, if you actually need to use the inverses, which you often don't, fortunately, if you don't need to go a different direction in your, for any restriction or anything, then don't bother naming inverse. And if you do need to name the inverse, then sometimes it's a struggle. So another example is we could use the same pattern to say an address, use a verb, the address locates Joseph. This works technically, grammatically, but again, it's pretty awkward. You wouldn't really do that. A more natural way to do it is to flip it around and say Joseph has a location address. And now we have to think of words and names that kind of halfway make sense. Joseph has an established location. This established location is an established location of this person, blah, blah, blah. So it's all kind of annoying. I'm going to skip over this. It's just kind of making the general point. So one thing I've thought of, again, you may like it, you may not. I don't know if I like it myself. It's just one other option. You could say, well, this is the located thing on, Joseph is the located thing on this established location. And then if you're sitting on the temporal relation, which points to two different things. So in the supervising case, it points to the supervisor and the supervised. In the established location, it points to the located thing and the location itself. So that can work, for education, the educator, the educated, the supervisor, the supervised, the employer, the employed. So these are just options. Again, it is a struggle to think of names that make sense. So this is just one possibility. So that's names. I'm not saying here's some names, you should use them. I'm saying, we've struggled with this and we've thought of some names that kind of sort of work. But honestly, here personal preference plays a big role. People can get very attached to their names and they might not think much of yours. That happens all the time. All right, so summarizing our little spiel here on temporal relationships, it's something that commonly arises in the enterprise, even a small company like Semantic Arts. We realized, gosh, we really want those things for billing rates, so we added them. It's a relationship holding for a period of time. Some are very much like events, but others not so much, and then we went through the formal definition. You can use property chains to link the non-temporal and temporal approaches, either using OWL, which has limitations as we talked about, or just to do it in Sparkle on the application side. We talked about some limitations. Property chains seem like a great idea, but they're not fully supported, and they have some limitations, and I've come around to where I'm like, I just can't be bothered. I got burned a number of times. I put a cardinality restriction and it wouldn't work. I'm like, damn, what's that about? And I'm like, I can't be bothered with this crap. So I don't use all property chains anymore. Just if we need property chains, do it in Sparkle. Dates are quite a lot of a nuisance. We talked about that. We're still kind of struggling with that. Dave's got some ideas and we're implementing them. It's not fully baked at the moment. And again, names for these properties, when you introduce this new layer, you kind of run out of reasonable English words and expressions. Have a few suggestions. You might like them, you might not. So that's pretty much it. I had a few other slides on reification, but I'm not going to go through those. So thank you, everyone, and I will turn off the record now.